Good morning, students. The today's new chapter is chemical bonding and molecular structure, which is an important chapter to understand how molecules are formed, what type of relation is observed between different types of elements, the structure of the molecule, the basic geometry of different molecules and different compounds. This is the most important basic chapter, as I said, to understand the chemical reaction between various molecules. This chapter really helps us in various ways. So the chapter is chemical bonding and molecular structure. Chemical bonding and molecular structure. So in this chapter we are going to learn the bond between atoms, bond between ions, bond between molecules. In simple, bond between chemical species, as well as the structure of the molecule. Now let us understand what is chemical bond. Chemical bond is the bond between chemical species. Wherever there is a bond, that means a relation. Relation is observed whenever there is a force of attraction. Even if you take friendship is nothing but between two persons or three persons, that is observed only when attractive force or the attraction is observed. So similarly in chemical bond, just it is an attractive force between atoms or ions or molecules. It is the force of attraction between atoms or ions or molecules. So what is the force of attraction between atoms? You see here, hydrogen is an atom, another atom hydrogen. Okay, the force of attraction between these two hydrogen atoms is chemical bond. Here both the atoms are of the same elements, hydrogen chlorine. Here also two atoms. There is a force of attraction. Now ions. You see Na plus is a cation and Cl minus is anion. Oppositely charges attract each other. This attractive force is chemical bond. Similarly, magnesium oxide, Mg plus 2 and O minus 2. Oppositely charged ions attract each other. This attractive force is chemical bond. Similarly, between the molecules, here you see H2O and HF. Here oxygen is more electronegative atom and hydrogen is less electronegative. So here the bond between the force of attraction is between the molecules. This force of attraction is also called chemical bond. Why this attractive force is observed? Why the force of attraction is required? That is only to attain the stability. So chemical bond is formed to attain stability. Chemical bond is formed between atoms or ions or molecules to attain stability. Next, the formation of chemical bond is always exothermic. Formation of chemical bond is always exothermic. What it means? When bond is formed between atoms or ions or molecules, they release certain amount of energy. That means the process of formation of chemical bond is exothermic. Formation of chemical bond is exothermic. Formation of chemical bond is exothermic. For example, you see here hydrogen and hydrogen. Atoms, both are atoms. A single atom cannot exist independently. Why? They are unstable. Unstable. Why unstable? They are with high energy. High energy. High energy. Unstable and high energy. So they combine and form hydrogen molecule through chemical bond. So this is a molecule. So this one is stable. Stable means less energy. Less energy. So what happens to the energy? Here high energy, less energy. So that means certain amount of energy being released while forming the chemical bond. So therefore, formation of chemical bond is always exothermic process. So energy being released in the formation of chemical bond. So I repeat students, chemical bond is nothing but the force of attraction between atoms or ions or molecules. So here between the same atoms, different atoms, ions and molecules. So chemical bond is formed only to attain the stability. So formation of chemical bond is exothermic process, means while forming the bond they release energy, that is why exothermic. Exothermic. Now we need to understand, okay, what happens during the formation of the bond and energy related terms, okay, how bond is formed with related to energy through graphical representation. Graphical representation. Right, you see here, this is hydrogen atom, first hydrogen atom. At the center of the atom there is a nucleus and the outer shell contains electrons. Now let me take one more hydrogen atom, nucleus, outer shell electrons, nucleus and outer shell electron. Here let us see the force of attraction and force of repulsion between the two atoms. Here you see nucleus of first atom and electron of second atom, H1, H2. H1 the first atom and second atom. The force of attraction, FOA, force of attraction between nucleus of first hydrogen atom and electron of second atom. Similarly, we can also observe force of attraction between nucleus of second atom and the electron of second atom. Why they attract? Opposite charges, nucleus with positive charge, electron with negative charge. In addition to this force of attraction, we can also repulsive forces between the two nucleus and the two electrons. So here repulsive force. Between the two nucleus there is a repulsive force. Similarly, between two electrons, repulsive forces. To attain the stability, they should come to each other. They should come too close to each other. When they come too close to each other, when force of attraction dominates over repulsive force. So here this is the nucleus. This is the nucleus of second atom. The distance between the nucleus of two atoms is internuclear distance. internuclear distance. Internuclear distance. And as you know that energy and stability are inversely proportional. Energy and stability are inversely proportional. To attain the stability, if they want to attain the stability, if they want to be stable, they should release energy and they should have less amount of energy. Now you see students, if you draw a graph between energy and stability, that is energy and internuclear distance. See here, energy barrier. The atoms are far away. The internuclear distance is very high. When force of attraction dominates, when force of attraction dominates, stability increases and energy decreases. Energy decreases as the internuclear distance decreases. After certain distance, when it is reaching, stability decreases and energy increases. So at this point, the molecule with less energy and more stable. So at this portion, high internuclear distance, here force of attraction dominates over repulsive force. Here also force of attraction dominates over repulsive force. So at this point, force of attraction is equal to repulsive force. At this point, force of attraction less than repulsive force. Here repulsive forces are dominating. Here they are equal. Force of attraction and repulsive force. Attractive force and repulsive forces are equal. Here attractive force and repulsive forces are not equal. Attractive force dominating repulsive force. Here, so at this point they are equal. So here bond is formed between two atoms. That is, here the atoms are hydrogen and hydrogen. So that means atoms are little far away from each other to overcome the repulsive forces. They are little far away from each other to overcome the repulsive forces. The nucleus will not meet each other. The electrons will not meet each other because repulsive forces dominates. So bond is formed between two atoms of same element or different elements when attractive force is equal to repulsive force. So this is the reason why bonds are formed between two atoms or attractive force is observed between two atoms or two molecules. Now, as I said, bond is formed between atoms or ions or molecule based on different elements or different types of chemical species. Chemical bonds are different types. Chemical bonds are different types. Now the topic is types of chemical bonds. Types of chemical bonds. Types of chemical bonds. Types of chemical bonds. And remember students, whenever there is a formation of bond, always valence shell electrons involves. I repeat, only valence shell electrons are involved in chemical bonding. No inner electrons are involved in formation of chemical bonds. Right. As you know that there are three different types of elements in the periodic table. Broadly 3 and minor 4. Metals, non-metals, metalloids, and then noble gases. Noble gases Generally, they won't involve in bond formation except xenon and radon. Metalloids, when you are talking about metals and non-metals, metalloids also comes into the picture. So in this chapter, we will talk about two different elements, metals and non-metals. Metals and non-metals. So if we can classify what are metals and what are non-metals, then we can easily understand this chapter in a brief. So the types of chemical bonds are, first one, ionic bond. Ionic bond. Second one, covalent bond. Covalent bond. Third one, metallic bond. Metallic bond. And the next one, coordinate covalent bond, also called day-2 bond. In addition to these, there are two more bonds, hydrogen bond, which is weaker, and van der Waals forces. Van der Waals forces.